Hey guys, welcome back to this tutorial. In the previous tutorial, we've seen how we can create arrays with the NumPy library, and we imported NumPy as NP, and I've explained why we did that. You can import it as anything, but the custom and the most common way of importing NumPy is using NP, and that's just since we'll be referencing NumPy every time, it wouldn't make sense for us to start writing numpy.array. It would be stressful. So that's why we are importing it as a shorter, we are using a shorter form, and that is NP. So yeah, let's import NumPy as NP and execute this. So in the previous tutorial, we've seen how we can create arrays manually. So there are some inbuilt methods in NumPy that we can use to create arrays. So let's look at this now. So we have something called zeros. So as the name implies, it will create arrays that consist of zeros. You might wonder why we would need this, but sometimes you might just want to create an empty array that will contain zeros and then you change the values later on. So as you move on, you would understand why you need some of these inbuilt methods. So here I can just simply say 5. So it will just create a vector of array. So you can see it's just a unidimensional array, just 5. So but if I indicate, let's say 5 by 5, remember we talked about shapes briefly. So this would mean that it will create 5 rows and 5 columns of zeros. So you see we have 5 rows and 5 columns. So this array has 2 dimensions. Same thing, I can create 3 dimensions, 4 dimensions. You just pass in the shape that you want in it. So that is for zeros. So we also have ones. We also have ones. So you'd guess right, as name implies, you just create an array that contains ones. So here I said 3 by 3. And to just create an array of ones, and it will be 3 by 3. This has 3 rows and 3 columns. And then we have something that we call empty. Empty and zeros is the same thing. It's almost the same thing. So empty means 0. It uses 0 as its values as well. So I said 5, so it's created a unidimensional array for me. So the last one is the I method. So the I function, it creates an identity matrix. What do I mean by identity matrix? So I said 4. So it will create an identity matrix that will have 1 in the diagonal, and it will be 4. These ones will be 4. So you can see we have 1, 1, 1. This is called an identity matrix. So that's just the major inbuilt methods of creating arrays. And we also have a range. It's similar to the range function in Python. So it will create a range of numbers for you. So it takes in 3 arguments, where you want the number to start from, where you want it to stop, and the step. So but if you simply just write one argument, it will just take that as the stop point. Like if I just put this 20, mp.range of 20, the default of the start is be 0, and the default step is 1. So it will start at 0 and stop at 20. 20 will not be included. So if I print this array now, you see I have 0 to 19. So 20 will not be included. But if I want it to start at 1, and then I want a step of 2, not 1, not the default one, you see I have 1, 3, 5, 7, like that. So that's just a range function. You find it pretty much useful as you go through your career in data analysis. So we've seen earlier we can check the shape of how we can check the dimension of an array. So we can check the dimension of an array. We can also change the dimension. Like if I create a range of 1 to 10, and I print this, okay, this will not give me anything. I didn't indicate it to print. And I say print array. You see I have just a vector, a unidimensional array of 1 to 9. And if I check the shape, print array.shape, this will just give me 9 by by 1. So the 1 is just the row, and this 9 is shows that this 9 comma just shows that this is a vector. It's a vector and it has 9 values. So I can reshape this, and I can say array dot reshape, and then I'll pass in the new shape. I can say array dot reshape 3 by 3, but mind you, when you are reshaping, you must reshape in the number that will be equal to this original number. Like the shape now is 9, that means that's 9 elements. So if you be reshaping, when you multiply the two numbers that you pass in as your reshape values, it must be equal to the whole total number of values in the array. So 3 times 3 is 9. So you cannot reshape. Okay, let me say reshape 3 by 3, and let's see what the output will be. So you see it has been reshaped. Formerly it had just 9. Okay, let's see, let's remove this shape here so that we can see. So formerly we had just 1 to 9, we had a unidimensional array, but after reshaping we now have a bidimensional array. That's 3 rows and 3 columns. So, but as I said earlier, you have to take note of the calculations when you are reshaping. So I cannot say reshape 2 by 4, because 2 times 4 is, you see, it will give me an error. Cannot reshape array size of 9 into 2 by 4. So 2 times 4 is 8. So it will, if it rearranges this array into 2 by 4, there will be one value that will be left out, and it simply can't figure out how to go about that. So if you want to reshape, it has to be the number, it has to meet the number of the total elements in the array. So let's create another array. Let's say array 2, and that should have more values. Let's say np.range of, let's say, 20. So let's say array 2, and let's check the shape before reshaping, or let's just print array 2. Let's print array 2, and then let's print out the shape array 2 dot shape. So we have 0, 1, 2 up to 19, and then the shape is 20. So it has 20 values, it has 20 elements in it. So now we can reshape by 20, we can reshape by 4 by 5, because 4 times 5 is 20. So this will be valid. You see, we have 4 rows and we have 5 columns. We can also reshape by 5 by 4. That is 5 rows and 4 columns. We can also reshape by 10 by 2. That is 10 rows and 2 columns. See, we have this. And we can say 2 by 10. 2 by 10. And that is just 2 rows and 10 columns. So I hope you understand the concept of reshaping arrays now. So you take note of the total number of elements in the array before you can reshape. So that is all for this lecture. See you in the next video. Thank you.